Marking possible.
Is it unmute?
Yes, sir.
Okay.
It is on. Sir, I
Sorry.
yes, sir. Hmm. Participant. Participants, it is my privilege to introduce today's speaker, Professor Narayan Prasad Padhi sir. He is Board of Governors, Chairman Board of Governors, MNIT Jaipur, Director MNIT Jaipur, and Director IIIT Kota. Chair Professor uh, IIT Palakkad Technology Hub Foundation, a professor of electrical engineering at IIT Roorkee, and founder head Mehta Family School of Data Science and Artificial Intelligence. Professor Padhi is a prolific researcher in the area of power system engineering and smart grid, and has authored over 300 high-quality journal papers, over 60 IEEE transactions with an overall citation of more than 10,000 with H index of 50 and I-10 index of 143. He has contributed significantly to the domain by securing 13 international national research grants with a funding of over 200 Indian 200 million, and successfully supervised 23 research scholars and currently supervising 21 research scholars, writing 6 books, securing patents, uh, developing online NPTEL courses. Professor Padi has visited positions at eminent international universities and established research engagements and institutional tie-up with universities from US, UK, Denmark, Italy, and Canada. He has collaborated with top industries and government agencies for research, laboratory development. As a knowledge partner, he is well recognized in international and national professional bodies, being Fellow of Indian Academy of Engineering, the Institution of Engineering and Technology UK, Institution of Engineers India, and Institution of Electronics and Telecom Engineers India, and has actively contributed in various capacities towards their growth. Professor Padi is a well-awarded and honored scholarly professional at the national and international levels, including Alexander von Humboldt Experienced Research Fellowship, Samantha Chandrasekhar Award, IEEE Smart City Jury Award, IEEE PES Chapter Outstanding Engineers Award from IEEE Power and Energy Society USA, and Boy Scout Research Fellow Award for Young Scientists. With this brief introduction, I request Sir to start today's presentation.
Okay. Thank you, Professor Nanda, for a brief introduction. A very good afternoon to all the participants joined online today. Probably, please do interrupt me in between if you have to raise any concern. Otherwise, you can write it down so that we can discuss during end of the class. Now, today my title will be Optimization Algorithm and their real life applications. Now, all of you, please try to understand. Let us go back to our school education, especially in +2. We have been introduced optimization for the first time. So, if you all recall, if there is a function which is y equal to f of x, and I need to find the optimal points so that the function is either maxima or minima. So just recall that we used to take the first derivative and then equal to 0 and then move to the second derivative, substitute those points in the second derivative, and if the value is negative, we call it is maxima. If it is positive, we call it is minima. That is what being introduced to us during school education. But the challenges are why it has been equated to 0, why it is negative for a maxima value in the second derivative, and so on and so forth. Now let's say today, if I give you a function y, which is let's say m of x, which is a linear function, and if you differentiate that function, then it becomes constant, and if you go for the second differentiation, it becomes 0. So you are quite helpless that why my school education is not directly applicable to a function which is y equal to mx or y equal to 6x or y equal to 5x. So all the basics that has been taught to us in the school is not applicable to a function which is linear. That means it is also important to understand the nature of the function for which optima is possible. Means if the function is oscillatory in nature, it is like a hill, top, and then you come down, again you climb, until unless that happens, and which is perfectly known as concave or convex functions, then only the optimal point identification is possible. Okay, so let me, with this basic background, try to understand more about optimization. So what we do, once you optimize any given function, we need to also identify the variables of that function f of x. It could be f of x1, x2. It could be f of x1, x2 up to xn. And those variables decides the value of the function that need to be either maximized or minimized. Now the worrying part here, does those variables do have some restrictions? Whether does it possess some minima or maxima value within which the function has to maxima or minima? So we need to identify whether the variables which are being part of my objective function does possess some sort of restrictions within which that has to operate. And the moment you say the function f of x, which has to be popularly known as actually objective function, and that function either you can maxima or you can minima, or you can maximize or minimize, but subject to constraints, and that constraints may be equal to 0, which is popularly known as equality constraint, and if it is less than or equal to 0, which is popularly known as inequality constraints. Now I will slowly move to a little bit of again school education, where we have been asked to solve two linear equations, means 2x plus 5y equal to 9 and 3x minus 3y equal to 7. And we need to solve those equations, am I right? So you can solve linearly by obtaining x and y, and then you can say these are the values for my x and y. And sometimes you have been asked to solve or obtain the solutions of x and y using a graphical method. Okay, so what you have to do, actually you have to take a graph sheet, then plot the first equation, which is quite linear, then plot the second equation, which is further linear, and then from those intersections you can determine the value of x comma y. Now the moment you say equality constraint or inequality constraint, probably the area within which the point can oscillate will be your inequality constraint, where you say it is a function g of x which is less than or equal to 0. The moment you say equality constraint, h of x equal to 0, so then probably it is defining a particular straight line equation or a point which defines your equality constraint. So if you solve a numerical problem solving two linear equations using graph, probably that will help you to understand more about what is equality constraint and inequality constraint. Now quickly, let us just catch up a problem, which is a function that need to be optimized. 6x1 plus 11x2, that is my equation, that need to be optimized, okay? So for what value of x and y, the function will be maximum. Now, I just like to give a condition where x1 is greater than or equal to 0 and x2 is greater than or equal to 0. So what will happen when x is positive, x2 is also positive. So certainly to have maxima, I can move up to infinity for x, I can move infinity for x2. And when I substitute these values, the z will be very, very huge. But we do not want to come to a point where the solution is infinity, all right? Sorry. So there are two restricted equations, constrained equations, where they say 2x1 plus x2 is less than or equal to 104. What is 2x1 plus x2 less than or equal to 104? Please, all of you, try to solve this problem using your graph paper. Not now, but at least tonight or maybe tomorrow. You can just practice. So when you draw that line, 2x1 plus x2 is less than or equal to 104. That will provide a huge space below a straight line where the solution is possible. Similarly, when you say x1 plus 2x2 is less than or equal to 76, that is another straight line will give you a huge area within which it is going to satisfy. Now, when there are two constraints, so probably you can find out the common area that is satisfying both 2x1 plus x2 less than or equal to 104, as well x1 plus 2x2 is less than or equal to 76. And within that area, you have to maximize. So you can find the maximum point between these two common areas satisfied by these two constraints as defined earlier. You will get the maximum value of z for a given value of x1 and x2. So this is a solution. Problem solving is one issue. Understanding a maximum problem is another issue. Similarly, we can solve one more problem using minimization. So you can also try to solve this problem. I think as per the textbook is concerned, there are n number of optimization problems defined in different literatures and textbooks. However, selectively, few optimization problems which are defined as continuous optimization, discrete optimization, convex optimization, non-convex optimization, linear optimization, and nonlinear optimization. Now, engineering perspective, I think linear and nonlinear optimizations are considered to be one of the important aspects of optimization and quite complicated too. Now, let us focus a little bit on linear optimizations. Now, what is linear optimization? Because where the equations are quite linear and we need to optimize a function with different variables, and the constraints are a11 x1 plus a12 x2 plus a1j xj, a1 and xn, where a11, a12, a1j, a1n, they are the coefficient of the equation. Similar to my previous discussion, if you see, so this is 2 and 1 in the equation 2x1 plus x2 less than or equal to 104 are nothing but the coefficients, but I'm enlarging to a nth order problem, and hence this looks so big and complicated. Sorry, the variables A, B, C, all those variables are not necessarily to be positive. It could be either positive or could be negative. Now we'll try to understand one case study, and what it says, suppose a company manufacturer uh, which manufactures two different type of electric vehicles. One is A type, the other is B type. And both vehicles go through two technical processes for manufacturing. The first technical manufacturing and the second part is going to be a finishing part. So in the case one, vehicle A requires 2 hours of manufacturing and 1 hour of finishing. And the second one, the vehicle B requires 1 hours of manufacturing and 2 hours of finishing. Now the question is, the manufacturing units runs for 104 hours per month and finishing unit runs for 76 hours per month. Now the profit on selling one vehicle A is 6 lakhs and for the vehicle B is 11 lakhs. Now the company can sell all that it produces. Assuming that condition, now the question before you, how many of each type of electric vehicles should be manufactured to obtain the best return or to have the maximum profit? Sorry. I think I'll give you 30 seconds to all of you. Please take your pen and paper if possible and try to solve and give me an answer, or you can type in the screen if possible. Now, what does it mean? In the meantime, you just keep on working, keep on thinking. Let me try to help you how this problem can be addressed. So there are two variables, as you could see. One is manufacturing variable and the other is going to be a finishing variable. And you need different hours for each processes. And there is a maximum limit to each hour of manufacturing and hours for your finishing. Now you have to design, you have to strategize that what kind of vehicle I need to produce, either vehicle A or vehicle B, and how many number so that my profit or the return will be maximum. Now, let the manufacturing company manufactures X1 and X2 vehicles of type A and type B respectively. So the profit, as it has been mentioned, it is 6 lakhs for the vehicle A and 11 lakhs for the vehicle B. So the profit will be 6 lakhs times the number of vehicles that I produce and 11 lakhs times the number of type B vehicles that I produce. So first is known as my objective function or the master equation, which is Z, which is 6x1 plus 11x2 has to be maximum. Sorry. Now, the second very important part, all of you try to understand, that the total time to manufacture X1 of vehicle type A and X2, which is vehicle type B, which is 2 hours we required manufacturing for type A and 1 hour for the type 2. So 2x1 plus x2 is the manufacturing time, and the maximum manufacturing time available to me is 104. So one of the constraints that is restricting me, my optimization problem, is that 2x1 plus x2 has to be less than or equal to 104. Similarly, if I go for the finishing hours, again for the type A it is 1 hour, for the type B it is 2 hours. So x1 plus 2x2 must be less than or equal to 76. So these are the restrictions. And naturally, x1 and x2 both are going to be positive. Rahul, thank you very much for providing the solution very quickly. But let us check whether you are right or wrong after a few seconds. So what I wanted to say that, the problem is now formulated. We are maximizing 6x1 plus 11x2 with two different constraints, 2x1 plus x2, which is less than or equal to 104, x1 plus 2x2, which is less than or equal to 76, and both x1 and x2 are positive. If you solve this problem, sorry, as I told you, it is I think, don't feel bad. It is a 10th standard problem today in CBSE, graphical way of solving this problem. So if you solve and finally you will come to know the value of actually optimal point, which is 44 and 16 is the cross section point that shows that one variable is your 44 and the second variable is going to be 16, and the total maximum value is going to be 440. So the answer is x1, which is 44, x2, which is 16, and the objective function, which is going to be 440. Now this is being solved graphically. If you wish, we can also try to solve through conventional approaches. Now what happens, because that is too simple, because all the variables are linear in nature. But the moment it becomes non-linear, let us look into this example Z, which talks about 20x1 plus 16x2 minus 2x1 square minus 3x2 square. It is not necessary that all the time the objective function has to be linear. Sometimes it is linear, sometimes it is non-linear, sometimes it is mixture of this, all right? So if it is going to be non-linear, I think the problem becomes quite complicated because I cannot solve using graphical method the way we have solved the previous example. And the constraints are similar to linear constraints, and both x1 and x2 are positive. Let us see how we are going to solve it. Now, my suggestion to all of you that please try to get into a textbook in detail, because nonlinear optimization itself is a big, kind of a story. So you can use either Newton-Raphson technique or you can use Gauss-Seidel method. So there are multiple nonlinear optimization techniques available through which one can solve nonlinear optimization too. Okay. We are not covering actually those problems, nonlinear optimization in detail, such as Newton-Raphson and Gauss-Seidel, as of our Taylor series, for an example. So we are perhaps actually just giving an idea that nonlinear problems also can be solved. Now there are systematic dual problems. You might have heard a little bit about dual optimizations. So this is one example. Let us try to solve it. So if the question would be, write the dual of the problem, which is to minimize z equal to 3x1 plus x2, such that 2x1 plus 3x2 is greater than 2, x1 plus 2 is greater than or equal to 1, and both x1 and x2 are positive. So probably anyone can create a symmetric dual to any equations, and the applications I'll be talking in due course of time. Now, this is what I have already discussed during my beginning of the lecture today. So during school hours, I mean 10th and 12th, we have been taught, especially in 12th standard, that you have a function which is convex, which is oscillating. You differentiate and equal to zero. What do you mean by differentiate equal to zero? That means if you see the right side characteristic, the moment it reaches to its maximum point, that means you don't experience any change. So the rate of change of y with respect to x become constant, at that given point of time, and hence dy by dx become equal to zero. And that rate of change is going to be positive in the left half and going to be negative in the right half. So the gradient based optimization is based on the basic concept of rate of change of y with respect to x, and whether it is positive or negative or zero, and based on which actually we determine. So what we do normally for any function y equal to, let's say, 3x square plus 5, or some set of 3x1 square plus 3x2 square, and then we differentiate with respect to x1 equal to 0, and then find the variables, and then substitute the second differentiation to understand whether it is maxima or minima. So at beginning or end of the curve, start taking derivative at fixed step size. So we move slowly. Process continue until and unless the slope changes from positive to negative or vice versa, where the algorithm assumes presence of maxima or minima. So here you could see the maxima point, but if I revert it, then it will be a minima point that can also be identified. Now here I like to disclose a very important point actually, which has not been very thoroughly described in most of the textbooks. What happens, let's say I do have an oscillatory sinusoidal characteristic, all right? And I have to maximize sin x, okay? So any sin x maxima, what is maximum value of sin x? Any one of you? Okay, great. So that means you know what is maximum value of sin x. Similarly, you can also do it for cos x, okay? Now my worry is that if it is a oscillatory, Neeraj, thank you very much for a great answer, okay? So now what I wanted to say, that if this is going to be oscillatory function, but the amplitude, that maximum amplitude of 1, which is normally attained in my sine function, okay, it is a oscillatory but slowly decaying to 0. All right. So that case, if I have to optimize, then the value could be 1, the value could be 0.9, the value could be 0.8, the value could be 0.7. That means your maximum value is going to vary depending upon the starting point. Means if you start from a scale at a given point, immediately the value that it will come across after a few seconds, and the moment the derivative dy upon dx equal to 0, it will exit, saying that, oh, it has reached its maximum point. But which is not true. It may so happen that I may have an oscillatory function which is keep on decaying, and then again it is increasing. So that case, you may come out with a result, or the program may exit without reaching to its maximum point if it is oscillatory and continuous and varying. So those functions cannot be solved using those basic classical technique of gradient based optimization. So for that, we will look into other opportunities. Probably some of my colleagues will be covering different actually AI models for optimizations, and through which those kind of problems can be addressed. Now, gradient descent algorithm, which is very, very simple, which talks about that x of k plus 1, which is xk minus or plus mu k times delta f of k. So we go for a small step size of mu of k. We keep on increasing until unless there is no significant change being seen from the previous iteration to the next iteration. Now this is one of the convergence characteristics. And one thing I like to highlight here, that those gradient descent algorithms are applicable mainly to nonlinear optimization. All right. So when you have an equation which is nonlinear, you can go for gradient descent algorithms. Sorry. Now, just because it is not fun to solve a problem which is to optimize x1 plus x2 or x1 square minus 2x square, we are not interested. That is fine, understanding, but we'll try to understand some applications. Now, one of the major application could be of any field, but being belongs to a electrical engineering field, I thought of explaining one application that talks about energy management in a smart grid. Now, first of all, I'll give a little bit idea about what is the current energy scenario of this country. Okay. Now, let's say if I throw an example to you, you like to minimize. How many of you are interested to minimize your electricity consumption bill at your home? Please raise your hand. Are you interested or serious to reduce your energy consumption bill? Oh, yes, Rajat is saying yes. Rest all are ready to pay any bill, am I right? Great, Rajat. Oh, I think everyone, Neeraj, oh, everyone is saying they like to save money. Oh, great. So wonderful. Okay, that's fine. That's fine. I could see the mood of the whole class. I think everyone interested to save money in their electric bill. Okay. So electric bill means what? It will calculate the unit of energy that we have consumed. I'm going back to 10th standard again. Kilowatt hour is the unit of my energy. The number of kilowatts used for the number of hours will give me the kilowatt hour, and that will be my unit. And based on the unit cost, you have to pay the electric bill. Now, if your consumption is less and the time of use is also less, means the kilowatt is low, the hour is low, then kilowatt hour is low, and hence my electric bill is low. Now, if you have to optimize, means let's say you have a rooftop solar plant in your home, and then you have battery, a small UPS. Do you have UPS at home nowadays? Most likely not, but some of you may be having UPS. So UPS is a small device that stores electricity or energy and disperse as and when the main grid is not available to you. Okay, in a very simple language, because all you may not be belongs to electrical engineering here. So the challenge is, if you have bit of solar energy available to you in the rooftop, and you have a UPS or a storage device which is available to you at your home, and then you have lights, fans, air conditioning, washing machine, micro oven, all the devices you are operating. Now, to reduce the electric bill, you need to minimize your energy consumption. And to minimize energy consumption, you have to consume less electricity. That means the free energy which is available to you, that is in the rooftop solar energy, that need to be utilized first. And once those energies are being utilized, then if you still have excess energy, then that can be stored in the battery. Then only you will be taking power from your main grid, for which you are chargeable. That too, once actually the energy is available to you fully stored by the battery, then you can stop taking energy from the main grid and you will start discharging your battery. So what I wanted to highlight, the energy management in a residential house is very, very important to reduce your electric bill, subject to you have a controller which has that optimal nature of controlling your devices connected to your home. Okay, so if someone asks you, can you create or design an optimizer which will manage the energy in my residence? And this is what we call it as energy management in smart grid, which is a larger perspective. But in a theoretical way, my objective is that consume energy in such a manner based on your available sources, optimize the resources, optimize your consumption pattern so that the electricity bill will be very, very minimum. But here, what we say today, sorry, at residential customer, the price of electricity is constant throughout the day. All of you please focus now, very, very important. But at 11 kV industrial consumer level, the price of electricity is going to vary. That means The price of electricity may be X rupees in the morning hour and Y rupees at the evening hour. Example, rupees 2 during the daytime and rupees 3 during the evening time. Now I'm making a problem for you. All of you, please take your pen and paper. Now, if you have an industrial house, the example that we have solved for linear optimization for vehicles to be manufactured A and B, which requires 1 hour and 2 hours respectively for manufacturing and 2 hours and 1 hour respectively for finishing. There we have ignored the energy consumption bill. Now let's say if someone enforce that the consumption of energy is also a variable to decide your manufacturing pattern, the nighttime manufacturing will be, evening will be costlier, night will be cheaper, day will be moderate, then you can have another pattern of manufacturing where the minimum electricity will be consumed. To witness, you can just look into all the manufacturing industry of this country. They operate almost in the midnight. Okay, there are 3 shifts, but majorly 2 shifts, 1 shift in the day and 1 shift for sure during the night hours. Do you know what is the reason of operating night hours? Just because the electricity cost is 50% and more cheaper compared to the day hours. All right. So if you like to do some optimization, and if the electricity cost is going to be a variable one, then the energy management problem becomes too complicated. Before moving to the next slide, I like to give one more example for which your mom will be very excited. Now let's say, if I say the electric bill is going to be 50% cheaper during 11 p.m. and it is going to be 50% costlier during 7 p.m. So how do you advise your mother to use the washing machine, whether it is in the evening hours or it is going to be in the night hour? Any one of you, please suggest. Will you suggest your? Excellent. Thank you. Thank you, Akash. I think it is the night hour. Okay, Rahul, thank you once again. So night hour, you recommend your mom to run the washing machine because the energy cost is going to be cheaper. Now, this is a very, very simple problem. But if you want your mom not to be awake, if I say every hour it is going to change, then what do? You'll be very tired. Your mom may say, no, I'm ready to pay 200 rupees extra, but son, don't disturb me to be wake up around 11 p.m. to make sure whether the washing machine has to run or not. So that case, you need a optimizer who understand all the variables, x1, x2, who understand all the costing variables, that is the energy bills, and then instruct each and every device to operate in such a manner so that your overall energy cost become minimum. So those who are undergraduate students, could be an assignment problem to all of you. Please see to that whether you can address this. So this is what actually I have already discussed. And if you are interested, please go through some of the research articles which has been published in IEEE Transaction in 2017. But this is slightly complicated problem. It was not so simple the way I have explained, but you can just read it to enjoy understanding the energy management scenario. Sorry. Now there is one more interesting problem. We need to forecast the weather data, which is a decade-year-old problem. Almost, I know it is a 40 to 50 years old problem to me, and probably more than 60, 70-year-old problem. How to forecast? Okay. What do you mean by load forecast? Means at a given point or a given hour, how do I understand the requirement of energy? That is known as load forecasting. I will tell you a very simple example here. Now, the consumption of energy, so the moment you switch on your light, the light is getting on or not? If I switch on, whether the light will glow or not, any one of you, yes or no? Yes. Akash is saying yes. Mohit is also saying. Everyone is saying yes. Sachin is also saying yes. Okay. So the moment I switch on, the light has to glow. All right. Now, who has provided that additional energy? How do I get that energy? Because there are just an example, it is one switch. But if I switch on 100 switches, or if I switch on million lights at a time, still it is glowing, okay? How it is happening? Huh? Someone is saying load on provides. Any other suggestions, please? Sorry. Any other suggestions how those lights are glowing immediately after I switch on? Uh, okay, okay, okay. Electrons flow. Very good, Rajat. Agree. But where that electrons comes, my dear? Hmm? A flow of electrons is very high. Okay. Okay, Akash, generators switched on. Very good, Akash. I think this is a good answer from the grid. Mohit is saying from the grid. Okay. And oh, I think Subrat, you are very intelligent. It is inertia. Thank you. Sorry. So what exactly happens that it is coming from the generator, that is true, but the generator is a mechanical device. So because it is a mechanical device, it may not be able to run immediately. It takes a couple of seconds or minutes to generate that excess energy. And by the time it is ready to generate, my load scenario may be different. I cannot wait for a few seconds for my light to glow. So there is an inertial mechanism. I'm not getting into that, but I've just wanted to highlight why forecasting is important. So if I'm not well prepared that in the next hour, the energy requirement of this country is going to be X gigawatt, I cannot make my generators use nuclear power plant, use super thermal power plants to be ready to generate. So it is very important if you are not aware what will be my load tomorrow or what will be my load next 1 hour, then what will happen? The load will appear, we consumers will keep on using energy, but the suppliers may not be able to provide. So there will be a cascade failure and finally the whole country will be black. All right. So to avoid darkness, each and every utility of this world must know the approximate energy requirement for next hour, next week, next day, all right, next year, and so on and so forth. So forecasting is going to be an interesting problem. Sorry. But if you do not forecast it properly, what will happen? Means you need 10 gigawatt and that was erroneous. So then you generate 10 gigawatt, make the generators ready to generate, but you are not going to consume. So it's a great loss to economy. And if it is vice versa, that means you predicted 5, but the load is going to be 7. So then 20 to 30% of consumers will not get electricity. So it is important to predict the load priorly with minimum error so that the country's economy and energy scenario will be intact. So this is a very, very interesting problem, which is basically error optimization we called. And all of you please focus on this problem, which is quite important. So today the forecasting problem becomes generation forecasting problem, because the renewable energy, which is a very interesting topic, where the solar energies keep on varying. Okay, today it is sunny, tomorrow it is windy, day after tomorrow it is cloudy, and nobody knows how much energy is available to me from the renewable energy. So it is also important to forecast, and therefore that forecasting you have to maximize the renewable generation available to you so that accordingly you can optimize your rest of the activities. So forecasting the load, forecasting the generation in the current scenario of renewable energy market become very, very important. And these two are complicated optimization problems. Now the last section, what I'm coming into, please note down the transaction article, very, very interesting. for the first time in this country of such article which has appeared in 2015, where we try to address little bit of DSM problem using some optimization techniques. Now, what is happening today? All of you, please remember the requirement of energy during the evening hour is going to be maximum. Why it is maximum? Because almost each and every street light has to be switched on. Each and every airport need to be lightened, as well as the renewable energy available to me during evening hour is minimum. So there is a bigger challenge. The peak demand issue during 7 p.m. become a critical point. Now what happens if you have to meet that load requirement at 7 p.m.? Let's say it is 100 gigawatt. Okay, so you put a plant which is of 100 gigawatt to meet the peak requirement at 7 p.m. But what happens during midnight? Midnight, that demand will not be there, but the generator will be unnecessarily running, or you made a huge investment, which is 100 to 200 or 500,000 crores of investment for a particular hour of the day where you are not able to fully utilize. So it is a loss of economy, am I right? So if you have invested something, you have to make sure that is operational, the plant is operational at least for 20 to 22 hours in a day, or even throughout the day. So to do that, you need to reduce the peak requirement of the nation or the state or the city or the home. Now, if you reduce the peak requirement, then what you to do? The consumers of the country is fixed. Let's say in my home, I may suggest that you do not operate your washing machine during evening, operate during night hours. But the energy has not been reduced. All of you, please try to understand. Those device has to run either in the morning or evening. So the area under the energy curve or the energy consumed throughout the day is going to be same, because 2 hours you have to run the washing machine, 1 hour for the micro oven, 4 hours for electric cooker, all those things has to run. So the energy consumption is not going to reduce. All of you, please remember. But the energy cost is going to reduce depending upon the time of use. So similarly, in the demand side management problem, what we do, we encourage our consumers not to use their devices during peak hours. During peak hours, because the load curve is a value, sometimes it is off, sometimes it is peak. So we request the consumers not to be operational or active during peak hours. So when they are not active during peak hours, what will happen? They will consume it in some other time which is off peak. So if the area remain constant, by keeping the area constant under the load curve and reducing the peak will help me not to install generators unwantedly or oversizing. Am I right? But how do you do that actually? For the nation, for the utility, it is very good thing that you do not increase your peak amount, okay? So it is almost try to make it flat. So this is known as valley filling, okay? So whenever you have off peak, you put some customers there, and whenever there is a peak, you reduce some customers there. So what will happen? Instead of a sinusoidal characteristic, it will be a pulse characteristic, or is a low peak characteristic. And if you can achieve that in energy market, then that is known as demand side management problem. I will give an example. Today we are allowing free electricity to people, okay? So the moment you allow free electricity, so that means they can consume energy at any given point of time. I am not against free electricity, but I am against free electricity during peak hours. So if you give free electricity during 7 p.m., the country is going to collapse. So what we can do, morning 4 a.m., when almost all the industries are sleeping, all the consumers are sleeping, all the lights are not glowing, I can allow my farmers to pump some water free of cost for their farming, but the time is restricted between 4 to 6. So managing energy consumption for the overall benefit without harming the peak scenario is known as demand side management in layman's language. Now, one more interesting problem this country is going to face, which is very much significantly related to optimization, about electric vehicles. So electric vehicles are keep on increasing day by day. How many of you are interested to have electric vehicle next 5 years? Nobody wish to have electric vehicle next 5 years. I think seems to. Oh no, Rahul is interested to have it. Okay, Rahul want to have electric vehicle. Anybody else? I think they are students perhaps. Okay, no worry. So excluding Rahul, nobody is interested to have electric vehicle. Vishal is also interested. Okay. So I think now slowly I could see most of them are interested to have electric vehicle. So when you have electric vehicles, Haris already have a Tesla. Tesla like to have. Ganesh like to have one more. Okay. So almost everyone is interested to have electric vehicle. It's a very good idea. But how do you charge your electric vehicle? Let's say if we all charge our electric vehicle during 7 p.m., so then the country become dark. So there must be an optimal algorithm. There must be optimization. So, charging stations are not available, but nowadays many charging stations have come up. Rahul, if you go from actually Jaipur to Delhi or Delhi Bombay highway, almost every 20 to 50 kilometers you will find a charging station. And I'm very sure in next couple of years, whole country will have charging stations. So once you have the charging stations, uh, okay, Rahul Kumar ji, sir, in Bihar, no, Bihar also will have it. I say, nahi, don't underestimate. Each and every city of this country will have charging stations in next couple of years. Now, once you have the charging stations, the charging pattern is important. That means how do we manage those charging patterns so that they are being utilized maximum energy during the off-peak hours, and during peak hours, the vehicle charging can be reduced. Similarly, if I do have a large battery in my system, those batteries need to be charged during off-peak hours and must be discharged during peak hours for a better energy management of this country. So before I conclude my lecture today, what I wanted to highlight, these are all scenarios, demand response and energy cost. I've talked everything. Please go through the present publications for better understanding. But just to summarize, optimization, which is we started from your plus two education, school education, the basic optimization. Then we moved to linear, non-linear optimizations, and then gradient descents. And then we thought of discussing some applications of real time in the energy market or energy scenario today. So I hope this lecture was quite interesting. And if you have any questions, do not hesitate to drop me an email for further clarification. Thank you very much for wonderful and constant interactions. Thank you very much. Bye bye. Vishal, welcome, Vishal. Yeah.
Participants, if you have any query, you can type in the chat box.
Thank you, Rahul. Thank you, Mr. Kumar. Thank you all. Thank you all for reciprocating. Yeah. How it was? Okay. Yes, sir. नहीं इससे लग रहा है कि बच्चे काफी सीरियस है, वेरी इंटरेस्टेड. अभी तो ये आई थिंक विल सी टू दैट इफ पॉसिबल एक एप्लीकेशन जो है ना thoroughly बच्चे को समझाएंगे when he's
हाँ.
happy. All right. So what we can do probably not in a hurry. I'll just try to see that if I can explain one problem at least thoroughly because अभी तो वो theoretically they understood, but at least one problem in detail if they can understand that would be great. None is connect that new article. That is actually what has happened in 2015 10 साल पहले जब इलेक्ट्रिक व्हीकल नहीं था हमने कुछ एक्चुअली बैटरी के बारे में सोचे थे अभी वही बैटरी की इलेक्ट्रिक व्हीकल हो गया हमने बैटरी को चार्जिंग डिस्चार्ज